Hello, I'm Dr. McNasty. And I'm here to talk to you today about an app me and my lab partner have created for electrophoesis simulation. Basically, let me tell you what electrophoesis is first. Electrophoesis is when DNA is loaded into a chamber, and the DNA fragments that are created from enzymes that cut the DNA in specific places migrate a certain distance based on the DNA size. We have created a simulation because there's none existing on the market that will tell you how far DNA will migrate compared to a known that is on your phone. You need no lab equipment, no prior knowledge. You can just type a whole bunch of random stuff in and get a DNA fragment distance. Now let me show you what our app will look like. This board demonstrates what our app looks like. Right here you can see what our app design will look like on your phone once you download it from the Play Store or the iApp Store. You can see our patented design, and we are currently at version 5000. So this has been gone through numerous tests and has FDA approval. As you can see over here is the section of the app where you will type in the control that you have for your electrophoesis. You need a known for your electrophoesis so that you can compare the results that you have from the unknown enzymes that cut the DNA at certain locations. For the control DNA sample, you need to type in the type of DNA it is, DNA or RNA, possibly even lambda. You need to type in the lane that it will go into. Typically you do one. The buffer that you have planned using on with your agarose gel, typically you use a Te1X buffer. And then you also need to type in the type of gel you want to use. It could be agarose or a different type, and it could be to represent composition, predict its thickness, for different thickness for the DNA fragments to run through. You also need to type in the sample amount so that you know how much of the sample that you're going to load into the well as the control. And you also want to put the voltage that you plan on running this sample at. It has to be the same as the unknown enzymes that you're putting into the other section of the app so that everything can run at the exact same quantity for voltage.
Hello, I'm Dr. McNasty's lab partner, Dr. Pepper. Here, you can see the display for our revolutionary app. Over here you can see the information that you input when you put in all the information for the different samples. And after you run the simulation, you'll get a screen that looks like this, that has a simulation of the gel itself with the negative and the positive electrodes. And you also have the colors, because you have to assign a color to each sample, and you have the colors of the known samples and the unknown samples. And you also get the distances that each one traveled from its well. And using those distances, you can compare, and you can see which the unknowns are closest to, and then you can use that to find out what the unknowns are.